my dear student, I'm Mr. Kitwala from Educatives. I will be with you in physics for Form 5. So, my dear student, welcome for our new topic, which is called the properties of matter, for our subtopic of the surface tensions. So, before we proceed with our discussion here, we are supposed to understand this topic, the meaning of the properties of matter. Why we are going to see on what we are going to see on this topic here. So on our topic here, we are going to see how the matter behaves. How the matter behaves. What is the characteristics of those matter? Now, first of all, let us understand the meaning of the matter. As we have learned on form 1, we say that matter is anything that has weight and can occupy space. Anything that can occupy space and has mass and a weight we call as the matter. And we try to see that the matter have only 3 states. The first state is called the solid. The second is the liquid, and the third is also a gaseous. This is what we tried to see on Form 2 the properties of matter. So on this topic, we are going to see several concepts about the surface tension, about the elasticity, the elasticity, I think the capillaries, and its own characteristic. That is what we are going to see. How can we get the strain? How can we get the Barker modulus? That is what we are going to see on this topic here. But before we proceed with our discussion, let us start with the new subtopic, which is called the surface tension. So when we talk about the surface tension, my dear student, this is the ability of the liquid to behave like a full strategic elastic skin. That we see the liquid, we see either the liquid such as water. If we take a small droplet, if we take the small droplet, either the pieces of the paper and drop into the liquid or into the water, we see that the behavior or the amount of water provides some behavior, shows some behavior, because it forms the elastic skin. It forms the skin that have the tendency to elastic. It means to stretch it. Kama ngozi fulani ambayo inakuwa ina tabia ya kuweza kutanuka, ndio tunasema kuhusu surface tension. Kwa ukichukua tone lako moja, ukichukua chochote kile kitu ambacho kina uzito mdogo sana, ukakitupia kwenye maji, utaona kabisa kwamba yale maji yanakuwa na tabia ya kutengeneza ngozi, na ile ngozi inakuwa na tabia ya kutanuka. Yaani unakuwa unaona kama ile layer ya kwenye maji, ile ngozi ya maji inakuwa kama inaongezeka, inatanuka. Kwa ile process ndio tunaita the surface tension, my dear students. So let us see this concept related with the surface tension here. So surface tension allow object denser than water, like a paper clip, to float. As I told you that this is surface tension because it forms the elastic skin, enable the material which having the less denser than the liquid to float on that liquid. So it is caused by the attractive force. What is the reason that cause the surface tension? The surface tension is caused by the attractive force. That the force of attraction that occur on the surface tension. And that attractive force exert between water molecule. Kwa ile attractive force inakuwa ina exert katika water molecule, katika zile molecule za maji sana sana, creating the skin that minimize the surface area. So after that attractive force occur between the water molecule, create the skin that could minimize the surface area. Kwa hiyo inakuwa inatengeneza ngozi fulani ambayo inakuwa na tabia ya kuweza kupunguza surface area here. So surface tension in terms of the molecular theorems. Now we are going to see the surface tension in terms of the water molecules as we see in here. So surface tension arises from the cohesive force. As we know that this surface tension arises from the cohesive force. Kwa hiyo hapa inakuwa inatokea from the cohesive force between the liquid and molecule. What is the cohesive force? The cohesive force, my dear student, come from the cohesion force. This is the force of attraction between molecule of the same substance. Kwa ile force of attraction kati ya molecule zenye substance sawa tunaita ni cohesion au cohesive force. Ndio maana akakwambia sasa hii surface tension inakuwa inarise from the cohesive force between the liquid molecules. So the interior molecule are pulled equally. Those interior molecule is pulled equally, my dear student. But surface molecule experiencing can an inward pull. So this interior molecule are pulled equally, but the surface molecule zile zinakuwa kuna mvutano fulani ambao unakuwa unatokea, lakini ile surface molecule inakuwa ina experience the inward pull creating the strategic membrane. There are some membrane that have the behavior of strategy could appear. So effect that minimize the surface area. The effect that could minimize the surface area tunaita ni strategic membrane ambayo tunaita ni elastic skin. Kwa hiyo hapa inakuwa na tendency ya kuweza kuminimize the surface area. So this explain why the liquid form the spherical drops. This should give us the reason that why liquid form the spherical drops as sphere have that least surface for the given formula. So let us start looking about the energy of a liquid surface. Sasa twende tukaangalie energy of the liquid surface as we see here. On the energy of the liquid surface, we are going to see what is the energy appear on the surface of the liquid. We are going to determine either by using the formula, my dear student, here. The fact that a liquid surface is in a state of surface tension can be explained by the intermolecular forces. This liquid surface, which is in a steady surface, can be explained by using the intermolecular forces. In the back of the liquid, which begin only a few molecules, diameter downward from the surface of a particular molecule, such as A, as it is shown on figure number 1 for our sixth topic here, is surrounded by an equally of the molecule of all side. So let us look at the diagram that explain about the energy that occur on the surface of the liquid. We have our figure here, but here, my dear student, we have this water molecule. It means this is the liquid, and this is the surface of the liquid as it is shown here. This is the diagram that give us the appearance of the molecular forces in the liquid. How these molecular forces in the liquid appear. This is what we are going to see on our figure here. So, as we see here, my dear student, inside the liquid here, inside the surface of the liquid, we have the rain drops. We have the first rain drops, which is allocated by the letter A. And the second is also the rain drops, which is allocated by the symbol B, as we see here. Also, we have the letter C. The letter C here is allocated by representing the rain drops, which is for the third drops. Therefore, we can conclude by saying that here on this surface, on this figure, we try to see different rain drops. The first rain drops, the second, and also the third rain drops. As we see that, let us look for the first rain drops, which is labeled by the letter A here. So that inside this rain drops, we have the intermolecular forces that exert from the center of that rain drops. Kwa tuna hii rain, tuna hizi molecular force ambazo zimeokaa kwenye hii rain drops kama tunavyojaribu kuona, lakini nakwambia kwamba no inward forces on A, because here there is equal forces. Kuna force nyingi ambazo zimeexert kwenye hii rain drops. Therefore, because they act in opposite direction, kwamba moja ita-act kwenda juu na ya pili ita-act kwenda chini. Kwa hizi forces zita-cancel. Zikisha cancel, basi mle ndani zitatengeneza no any forces that act. Kwa ndio maana akasema kwamba no inward force that act on this rain drops A, kwa sababu ya ile cancel of the force, kwa sababu za force ambazo zimeact mle ni zinafanana, inayoenda juu na inayoshuka chini zote zinafanana. Kwa hiyo tutasema hakuna force ambayo ita-act kwenye ile rain drops, inside the rain drops. But for the body B here, as we see, my dear student, we observe that here we have the resultant inward forces on B. Kwa nini tunasema kuna resultant inward on the second rain drops? This is because, my dear student, because this half of this rain drops is dissolved into the liquid. Kwa nusu ya ile rain drops imebini dissolved in liquid, as we try to see here.